Okay, now that we've talked about addition of integers, let's talk about subtraction. Reviewing our three addition rules, if you have a positive plus a positive, you add and the answer is positive. If you have a negative plus a negative, you add and the answer is negative. And if you have a positive plus a negative, subtract number from 0 gives the sign to the answer. Again, if this confuses you, look at the vector additions that we did and study the additions of the vector ones, and now Alright, the subtraction rule is easy. Turn it into an addition problem and then follow the addition rules. That's it. How we do that is we're going to add the opposite of the second number. This is very similar to what we do with division of fractions. We don't actually divide fractions, we multiply by the reciprocal of the second fraction. So this is very similar to what we do in division of fractions. Alright, so let's take a look at some proofs using counters. In this case, we have a subtraction problem, and we're going to do this both in subtraction and as addition. So if we have 5 minus 3 equals 2, and we start off with 5 positive counters, we can take 3 counters away, and that leaves us with 2 counters. Simple as that. So what does this look like as an addition problem? Well, it would be 5 plus a negative 3. Notice what happens with the minus sign. It turns into an addition sign, but the positive 3 turns into a negative 3. So now we start off with our 5 positive counters, and we're going to add 3 negative counters to it. Well, here we go again, just like with addition, we have those 0 pairs occurring. And how many 0 pairs do we have? We have 3 of them. What means as that happens is those will disappear, and what we're left with is 2 positive. Alright, what about something like 4 minus 7 equals a negative 3? I know I've mentioned several times that you can't take a larger number from a smaller number, and so is indicated here. I don't have 7 positive integers to take away from 4. So we're going to use our 0 pairs again. We're only going to add as many 0 pairs as what's going to get us to be able to take 7 positives away. So in that case, we add 3 pairs of 0 pairs. And now we have 7 positive integers that we can take away, which, when we take those away, we're left with 3 negatives. As an addition problem, we have 4 positive integers. We add 7 negative integers, and again, finding those 0 pairs again, we have 4 sets, and when those disappear, we're left with a negative 3. Alright, our next example, a negative 1 minus 8 equals a negative 9. Well, we start off with a negative 1 integer, but we don't have any positives to take away from this, so we have to add our 0 pairs. We have to add 8 of them. So now we have enough positive integers to take away 8, and we're left with 9. Negative 9. As an addition problem, this is very straightforward. So a negative 1 plus a negative 8 is going to equal a negative 9. You just add 2 groups of negatives and you end up with a negative 9. Alright, this is the one that confuses most people because they think that the answer should be a negative 4. But let's see how it proves to be a positive 4 instead. If we have a negative 2 and we want to take away a negative 6, again, we don't have enough negatives to do that, so we have to add some 0 pairs, 4 to be exact. So here are 4 sets of 0 pairs. Now we have enough negative counters to take 6 away, and now we're left with a positive 4. If we do this as an addition problem, it would be negative 2 plus positive 6. If we have a negative 2, we add a negative 6. Now we have 2 sets of 0 pairs. which can go away, and we're left with a positive 4. Alright, so what I'd like you to do with these problems, and again you can pause after each one because the answer is going to follow, is just turn these into addition problems. So for example, if I have 8 minus a negative 7, all I want you to do is be able to say this is the same as 8 plus 7. Alright, so do that option or that operation with all of these. Okay, with this next set, go ahead and actually solve them. Now, what's going to happen is that second step is going to be missing. So, for example, on your paper, go ahead and write negative 5 minus 2. But again, write this as an addition problem. So it should be negative 5 plus a negative 2. And then go ahead and solve it, and the answer should be a negative 7. Again, go ahead and pause after each one of these so you can get the answer and then double check it. Okay, here is your assignment. Again, create 10 problems to show subtraction of integers. 8 of your problems must have negative integers in them, either in the expression or the answer. And challenge 2 or more digits in your problems have to have 2 or more digits. For example, negative 155 minus 10 is the same as negative 105 plus a negative 10 equal a negative 165.